Hi, hello, welcome to my channel Learn More Maths. My name is Vara Kumar. Today we are going to solve a problem from Polynomials exercise 3.1 first problem. So already we have discussed an introduction to polynomials. So next we are going to do some problems from the first exercise. See here what he is asking to find us. In P of x is equal to 5x to the power 7 minus 6x to the power 5 plus 7x minus 6. What is the coefficient of x to the power 5? Degree of P of x, constant term. So these are very easy, student. If you watch introduction to polynomials, you can answer very easily. So see here, already we have completed introduction to the polynomials in the previous video. First, before watching this, you have to watch it first. So next, see here, how can we find coefficient of x to the power 5? So the given polynomial is P of x is equal to 5x to the power 7 minus 6x to the power 5 plus 7x minus 6. So coefficient of x to the power 5. So here it is x to the power 7. So where is x to the power 5? This is x to the power 5. Minus 6 is called the coefficient of x to the power 5. So just we have to write minus 6, that's all. So coefficient of x to the power 5 is minus 6. So next, degree of P of x. So what is the degree? The highest power of the variable in the given polynomial is called the degree. So here the highest power is, what is the highest power? Here it is 7, 5, 1, 0. So what is the highest one? 7. That's all. The degree of P of x is equal to 7. So constant term. So without variable is a constant term. Here x is to the power 7 is there, x to the power 5 is there, x is there. So constant is also minus 6. Constant term is equal to minus 6. So that's all, student. Very easy. Just we have to understand the definition and the degree of the polynomials. This is the first problem in the first exercise. Next we have to solve second problem. This is the second problem from first exercise, student. Already we have completed first problem. So here he has given some statements. He is asking to say whether the given statements are true or false. And if they are true, give reason, he is asking, and if they are false, why they are false, give reason, he is asking. So see, student, we have to answer one by one. There are 5 bits. There are 5 statements in the second one. State which of the following statements are true and which are false. Give reason for your choice. So first one, the degree of the polynomial root 2x square minus 3x plus 1 is root 2 he has given. But root 2 is not the degree of the given polynomial. Root 2 is the coefficient of x square. So what is the degree? The highest power of the variable in the given polynomial. So here the power of the variable is 2, 1, 0. Highest power is 2. Therefore the degree of the polynomial is 2. But here he has given root 2. So we can write it as a false. It is not true. It is false. So why it is false? The degree of the polynomial is 2. But here he has given root 2. Hence it is false statement. So next, second one. The coefficient of x square in the polynomial P of x equal to 3x cube minus 4x square plus 5x plus 7 is 2. So he is asking the coefficient of x square. Observe, where is x square? Here it is x cube, here it is x square. Coefficient, this is the coefficient of x square. The coefficient of x square is minus 4, but here he has given it is 2, hence it is also false. So here simply you have to write false. So why it is false? The coefficient of x square is minus 4, but he has given 2, hence it is false statement. So next, third one. The degree of a constant term is 0. Yes, it is true. Degree of the constant term is 0. So it is true. So see here example. How can we say example? So constant terms, so there will be only numbers -4, -2, 2 by 3. There are no variables in the constant polynomial. Actually here he has to give constant polynomial, but he has given the constant term. So even though it is constant term, we can say the degree of the constant term is also 0. The degree of the constant polynomial is also 0, and the degree of the constant term in the given polynomial is also 0. So here these are the constant terms, the degree. So here -4 can be written as like this, 4 into x to the power 0 minus 2 into x to the power 0, 2 by 3 into x to the power 0. So here the degree of the constant term is 0, hence it is true. So next, fourth one, 1 by x square minus 5x plus 6 is a quadratic polynomial. So here it is not at all a polynomial. So here what is the definition of the polynomial? An algebraic expression in which the powers of the variables are non-negative integers, but here the powers of the variables are negative integers. So here x to the power -2, x to the power -1. So the total term is there in the denominator. If you take to the numerator, it becomes x to the power -2. So hence it is not at all a polynomial. So it is not a quadratic polynomial. We can write it is a false statement. So next, fifth one, the degree of a polynomial is one more than the number of terms in it. So here it is also a false statement. There is no relation between the degree and the number of terms. Degree is the highest power of the variable in the given polynomial, but he is saying that degree is one more than the number of terms. So it is a false statement. Degree is what? The highest power of the variable in the given polynomial. So here he has given one more than the number of terms. There is no any relation between the degree and the number of terms, hence it is the false statement. So this is the second problem from first exercise, student. So next we have to solve third problem. This is the third problem from first exercise. See here what he is asking to find as if p of t is equal to t cube minus 1, find the values of p of 1 comma p of minus 1 comma p of 0 comma p of 2 comma p of minus 2. So he has given a polynomial p of t is equal to t cube minus 1. He is asking to find us the values of p of 1 minus 1, p of 2 minus 2 and 0. So just we have to substitute in the polynomial p of t is equal to t cube minus 1 by t is equal to 1, 2, minus 1, minus 2 and 0, we can get the values. So see here, how can we find? So the given polynomial is p of t is equal to t cube minus 1. So if t is equal to 1, just we have to substitute t is equal to 1, we can get p of 1 is equal to. So we have to substitute t is equal to 1 in the given polynomial, we can get the value of p of 1. So here t cube, so 1 cube minus 1. So 1 cube is 1 minus 1, 1 minus 1 is equal to 0. So therefore p of 1 is equal to how much? P of 1 is equal to 0. So next he is asking to find as p of minus 1. So if t is equal to minus 1, so just we have to substitute t is equal to minus 1, we can get p of minus 1. So see here I am substituting minus 1, so we can get a minus 1 whole cube, again minus 1 is there, minus 1 whole cube is minus 1, that is minus 2. So here minus 1 whole cube minus 1, minus 1 whole cube is minus 1, again minus 1, minus 1 is minus 2, therefore we can write p of minus 1 is equal to minus 2. So next if t is equal to substitute t is equal to 0, we can get p of 0. So p of 0 is equal to, so wherever t is there, write is 0. So t cube is there, write 0 cube minus 1. 0 cube is 0 minus 1, which is equal to minus 1. Therefore we have p of 0 is equal to minus 1. Next he is asking to find as p of 2. If we substitute t is equal to 2, so we can get a p of 2. So p of 2 is equal to, so t cube, that is a 2 cube minus 1. So 2 cube is 2 into 2 into 2, that is 8. 8 minus 1 is equal to 7. Therefore we can write p of 2 is equal to 7. So next p of minus 2. So just we have to substitute t is equal to minus 2 in the given polynomial. We can get p of minus 2 is equal to, so t cube is there, it becomes a minus 2 whole cube minus 1. Minus 2 whole cube is a minus 2 into minus 2 into minus 2. We can get minus 8. Minus 8 minus 1, that is minus 9. Therefore p of minus 2 is equal to minus 9. So like this we can find the values of the given polynomials by substituting instead of the variables. We have to substitute the given numbers. We can get the value at the number. So this is the third problem in the first exercise, student. Next we have to solve a fourth problem. This is the fourth problem from first exercise. See here what he is asking to find us. Check whether minus 2 and 2 are the zeros of the polynomial x to the power 4 minus 16. So he has given a polynomial. He is asking to check and 2 and minus 2 are the zeros of the polynomial. So by substituting, replacing x by the given values, if we get the 0 of the value of polynomial, we can say it is the 0 of the given polynomial. Suppose let it is p of x is equal to x to the power 4 minus 16. By substituting x is equal to minus 2, we can get p of minus 2. If p of minus 2 is equal to 0, then we can say minus 2 is a 0 of p of x. So in the same way, we have to substitute x is equal to 2. If we get p of 2 is equal to 0, again we can say 2 is a 0 value of p of x. So see here a solution. How can we find? So let p of x is equal to x to the power 4 minus 16. So substituting x is equal to minus 2. Substituting x is equal to minus 2. So we get p of minus 2 is equal to p of minus 2. So wherever x is there, write minus 2. Here we get minus 2 whole to the power 4 minus 16. So minus 2 whole to the power 4 is plus 16 only. 16 minus 16, which is equal to 0. So since p of minus 2 is equal to 0, minus 2 is a 0 of minus 2 is a 0 of x to the power 4 minus 16. So next we have to check, substitute x is equal to 2 in p of x. So again substituting x is equal to 2. X is equal to 2. So we get, see here, p of 2 is equal to, p of 2 is equal to, so x to the power 4 minus 16. So it can be written as 2 to the power 4 minus 16. So just we have to substitute x is equal to 2 in p of x. Here x to the power 4 is there, 2 to the power 4 minus 16. 2 to the power 4 is 2 into 2 into 2 into 2. So we can get 16. 16 minus 16 is also equal to 0. Therefore we have p of 2 is equal to 0, therefore 2 is a 0 of 2 is a 0 of x to the power 4 minus 16. 2 is a 0 of x to the power 4 minus 16. Since p of 2 is equal to 0, we can say 2 is a 0 of x to the power 4 minus 16. In the same way, p of minus 2 is equal to 0. Again, we can say minus 2 is a 0 of x to the power 4 minus 16. Therefore, minus 2 and 2 are the zeros of x to the power 4 minus 16. Therefore, we can write minus 2 and 2 are the zeros of x to the power 4 minus 16. So like this we can check whether the given numbers are the zeros of the given polynomials by substituting in it. So this is the fourth problem, student, in the first exercise. Next we have to solve the fifth problem. This is the fifth problem from exercise of 1, student. See here what he is asking again. We check whether 3 and minus 2 are the zeros of the polynomial p of x when p of x is equal to x square minus x minus 6. So we have already we have see here this is in the same as a fourth problem. So just he has given two numbers. He is asking to find us whether the given two numbers are the zeros of polynomial p of x is equal to x square minus x minus 6. Just we have to substitute in the p of x first. If we get first, you have to substitute x is equal to 3 in p of x. If we get p of 3 is equal to 0, we can say 3 is a 0. And in the same way, we have to substitute x equal to minus 2 in p of x. If we get p of minus 2 is equal to 0, again we can say minus 2 is also a 0 of p of x. So see here given what he has given, I am writing see here p of x is equal to x square minus x minus 6. So substituting x is equal to 3, substituting x is equal to 3. So see here we get p of 3 is equal to what we get, p of 3. So p of 3 is equal to x square is there, it is 3 square, minus x is there, minus 3 minus 6. So 3 square is 3 into 3 9. Minus 3 minus 6 is minus 9, which is equal to 0. So we have p of 3 is equal to 0. Therefore 3 is a 0 of p of x. Therefore 3 is a 0 of p of x. 3 is a 0 of p of x. So this is a first one. Next we have to substitute x is equal to minus 2. Again we have to substitute x is equal to minus 2. Substituting x is equal to minus 2, x is equal to minus 2. So what we get, see here. So p of minus 2 is equal to p of minus 2. So in p of x, wherever x is there, we have to substitute to minus 2. So x square is there, we have minus 2 whole square, minus x is there, minus of minus 2, minus 6, right as usual, minus 6. So here minus 2 whole square is plus 4. So minus into minus, it is plus 2 and minus 6, right as usual. So here we get 4 plus 2 is 6 minus 6, which is equal to 0. Again p of minus 2 is equal to 0, therefore minus 2 is a 0 of p of x. Therefore minus 2 is a 0 of p of x. A 0 of p of x. So therefore 3 and minus 2 both are the zeros of p of x. So he is asking to find us whether 3 and minus 2 are the zeros of p of x is equal to x square minus x minus 6. Yes, here 3 and minus 2 are the zeros of p of x is equal to x square minus x minus 6. So very easy and important. Every time he's asking for 1 mark, or sometimes he's asking for 2 marks. So just you have to practice at least 2-3 times so you can get perfect. So this is the fifth problem from first exercise. So totally we have completed all the 5 problems in the first exercise. So next, that's all today's class. We will meet in the next class with another problem.